Problem I've got, I'm going to finish doing these problems, then we'll go to homework problems. Here's the problem that I have for you to do. And that is y is equal to x squared plus 2x minus 6, and y is equal to 3x. And I want you to find the area between the two graphs, between the two functions, please. Give y'all a minute or two to get it done. What's the first thing you need to do, folks?
Graph it.
Graph it or sketch it. Good job. Oh, we got a couple of extra people coming in. Who came in? Looks like Razaka came in. Who else? Tomlin. Looks like Tomlin came in. Am I right? Y'all just now come in? I'm looking for Tomlin on video. I don't see Tomlin and I don't see Razaka. Hopefully y'all will turn them on. There's Tomlin. Razaka, I don't see you. Turn your video on, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 4, 6, 8. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 8. I got 18 people. Mr. Razaka, I don't see your... I'm looking for Razaka. I see Tomlin. Razaka, please. And somebody keeps going in and out. It's making me dizzy. Razaka, where are you? Okay. I tell y'all that I want you to turn on your videos. If you don't turn on your videos, I'm just getting rid of you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think that's about right because it's counting me in the room. So, all right, so here we go. First thing you want to do is maybe graph it, sketch it. You know you got a y-intercept of -6. It's a basic parabola, so that means something like this. Y is equal to 3x. It's crossing at the origin and it's going like that. So it looks like we're wanting that area right there. So that's going to be the area. We got to set equal to 0. X squared plus 2x minus 6 is equal to 3x. X squared minus x minus 6 is equal to 0. X, 3, 2. You need a -3 and a +2. So it looks like we're going from 0, because we know we're going from 0 to, or we could, no, yeah, sorry. -2 to +3. So -2 is right there, and +3 is right there. So our antiderivative from -2 to 3 of 3x minus x squared plus 2x minus 6. There is your setup. Did any of your homework questions ask for the setup? Yes or no? Huh?
Yes, sir.
I told you they would. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've got people coming in again. Make sure. I don't see your videos. I hate to take the time and do this, but I got students that coming in and think they can just turn their videos off and just do whatever they want to, and we're not doing that. Mr. Smith, what are you doing? You're in a dadgum elevator? Mr. Smith, he's in an elevator. I'm gonna have to do this again. Where's Mr. Lowry? I know he usually turns his on. Mr. Lowry, you got your video on? I saw him come in.
Yeah, I just got home. I was just doing a couple things,
Okay.
but I'll keep it on.
That's all right. I appreciate it. I'd rather see you going in and out, because I got some students, they'll just come in and they'll just do whatever they want to, and that's not being part of class. Mr. Isaac, are you in? Your video, where's your video? Isaac, where are you? Spending class time telling people to turn on their videos. One, 2, 3, 4, 5. I still got 18, and I got 19 in the class. So, okay. All right. So that's your setup. So now we're going to move on to solving it. So the antiderivative from -2 to 3 of 3x minus x squared minus 2x plus 6 dx. And that's going to be from -2 to 3 of -x squared. -2x plus 3x is x plus 6 dx. -x to the third over 3 plus x squared over 2 plus 6x. Evaluated at -2 and 3. And when you do that math, it's about a half a page of math. And you're going to get it. I got 125 over 6. Yes or no? Somebody get that?
Yeah, I got that.
Okay, good. Now let's do it on a calculator, so everybody can see how to do it on the calculator to check your work. Pull up our handy dandy calculator. Y is equal to x squared plus 2x minus 6. Clear. Just go ahead and clear everything, because it's very aggravating to try to type over that stuff. All right, x squared plus 2x, x squared plus 2x minus 6 and 3x. and just graph it. And y'all see there it is. And you want this little area right in here. And you got your point. So you can go to Math and go down to Integration. And we're going from -2 to 3. And we're going to type in -x². Or you could do this. You could do 3x. So hit vars, function, y2 minus, if it'll let me do this, minus parentheses, vars. This is the first time I've tried this, so give me a second. Function, y1, close parentheses, and then dx. And enter. And somebody tell me what 125/6 is.
20.83 repeating.
Good job. I bet some of y'all didn't know how to use integration on a calculator, didn't you? Did you?
You showed us some last week.
I know, but did you know it before I showed you?
Oh, no.
Huh?
Nope.
Good. You learned something in here then. If you didn't learn anything, you learned how to use your calculator. Please don't take advantage of it. Please don't screw it up, okay? Please. Okay, so that's that one. Let's see if I got another one here before we do homework problems. Well, we could do this one. I don't know if we've done this one or not. Have we done this one? F of x is equal to natural log of x plus 1 plus 5, and g of x is equal to x plus 2. Have we done that one? I don't think we have.
No, we didn't.
Say again?
I don't think we did.
Okay. All right, I want you to find, now this one, I would probably suggest you find the intersection points on the calculator, because you don't want to try to solve this. You could, but you'd have to distribute the natural log, get the x's on both sides. You could, but it's going to be a yuck. So let's find the intersection points on the calculator. So y is equal to clear, clear. Okay, it's not clearing. What? Oh, it's got. Oh, Lord have mercy. All right, here we go. First one is natural log x plus 1, close parentheses, plus 5. We know we've got a horizontal shift of 1 to the left and a vertical shift of 5 up. And then the bottom one is x plus 2. And there is your graph. I'm going to zoom in, zoom box. There we go. So I'm going to find my intersection point. So I'm sorry. What am I trying to find? Oh, the second trace. Intersect. And yellow, blue, and the guess is right about there maybe. I got negative 0.98. What'd y'all get? Okay, thank you. Appreciate the communication. Second trace, intersect, and my guess is right about there. Don't hold the button down, whatever you do. I got 4.75. Is that what y'all got?
Yeah.
Thank you. Appreciate the communication. I would just go ahead and say the antiderivative from negative 0.98 to 4.75 of the natural log of x plus 1 plus 5 minus x plus 2. And the only thing you're going to be able to do is distribute that negative, and you might be able to get rid of the 5 and the 2. So antiderivative negative 0.98, 4.75, the natural log of x plus 1 plus 5. I'm not going to mess with it. Negative x minus 2 dx. And I'm going to leave that 5 with that right there. That's your setup. And from there, you know the antiderivative, you're going to break these up into 4. That's going to be 5x. It's going to be negative x squared over 2 minus 2x. And remember, the natural log, for those of you that don't remember, let's go back to the integration on your files. Well, as soon as I get there. I believe it is called integration. I'm just pulling it over, so you should have your cheat sheets already out. And if I could ever get it to come up. And I'm waiting. And I'm still waiting. That's why you need to print them out. Well, you can bring that x plus 1. Yeah. I thought I gave y'all one with the, hold on, I thought I gave y'all one with the natural log on it. Did I not? I'm looking for the integration. I thought I gave y'all another one. Did I not?
I don't think so.
I believe I did. I believe it's right here. There it is. I knew I did. There it is. All right, so finish that one out. Give you another minute or two. And I can tell you right now, I don't think you can do the natural log yet. That should be integration by parts, and you'd learn that in. So we're going to do this by the calculator. This must be a calculator-driven problem. So let's go to the calculator, and we're going to find the derivative between these two. So that's going to be math, antiderivative, and hold on, let me get out of this. Second, quit. Thank you. Second, quit. Clear. Now, math, antiderivative, and that's going to be from negative 0.98 to 4.75, and that's going to be natural log of x plus 1, natural log of x plus 1 I'm going to put that in parentheses, and also plus 5, close parentheses, and I'm going to put another set of parentheses up here. Second insert, minus parentheses, x plus 2, close parentheses, and then dx. And enter. All right, did y'all get 10.8 on your calculator? Yes or no? Somebody.
Yes.
Yeah, I got the same thing.
Okay, now let me give y'all a little bit of a warning. Ultraviolet minus voodoo. I'm going to show you this, but this is second count. All right. If you take U, if you have U dV, and you want to take the antiderivative of U dV, then you're going to do ultraviolet minus voodoo. Ultraviolet minus voodoo. UV minus the
We can't
antiderivative.
see your screen.
Oh, I'm sorry. Ultraviolet minus voodoo. And I'll just give you this. This problem you would have to do with ultraviolet minus voodoo. And this is Calc 2. You'll learn this in Calc 2. But this problem that I found is a calculator drill. Okay, now let's do a homework question. So this one right here, hold on just a minute. Let me answer this. I have to. I apologize. My mother has a new phone, and sometimes she calls just to call, and she forgets what time my classes are. Okay. Sorry.
What was the ultraviolet minus voodoo thing?
I'm sorry. Say again.
What was the ultraviolet thing you was talking about?
Ultraviolet minus voodoo.
Yeah.
You're going to see it next semester when you're in your second calc. It looks like that. And this problem, evidently, this problem that I found, the natural log, that is a ultraviolet minus voodoo. It's a Calc 2 problem, but you can do it on your calculator. But you will see the ultraviolet, this problem right here. To do this problem by hand, you're going to have to use ultraviolet minus voodoo. So, because you basically have something times something or minus something, and that turns into natural log of x plus 1 minus x plus 3, and that turns into ultraviolet minus voodoo. So don't worry about it until next semester. But you can do it by the calculator. All right, let's do a homework problem. Here is a homework problem that was sent in, and it is a test question. I'll tell you why it's a test question. It's a test question because people will skip it. What do you mean people will skip it? People will skip it when they come to it. And I want you to tell me why people will skip it. As soon as I could pull up email. Thought I had it already pulled up. All right, 140. And let's see where it is. Let me do it by subject, sort by subject. There we go. They're in order. So let me see if this is it. 6.2, 39, 12. Yep, there it is. Why would you skip this one?
It's E.
Because it's e to the x. We can't do that. What's the first rule besides rewrite? What's the first rule I've told you when you're doing these problems? What do you do besides rewrite? What do you do first?
Graph.
Graph it. So that would be the first thing you want to do. Graph it so you can see how to set the problem up. In physics, you know what that's called when you draw the picture? It's called a free body what?
Diagram.
Diagram. And if you're going into engineering, you better learn how to do free body diagrams in statics and dynamics, much less thermodynamics. I also made a C in thermodynamics. I was proud of that C. So we've got y is equal e to the x. Y is equal to e to the negative 4x. And x is equal to natural log of 3. Y'all gonna like this, because I'm gonna show you something else. So you take your handy dandy calculator and you hit y is equal, and you hit e to the x, e to the x, that'll be second e to the x, and then you hit e to the negative 4x, oh me. I'm about ready to have a meltdown, so y'all just ignore me right now. I was trying to put an X right there. Okay. And then go up to the top and hit X is equal to natural log of 3. And graph. I bet y'all didn't know how to do that, did you? Yes or no?
I did.
You're a winner. So now we can draw it. We know we've got something like this. And that's why graphing calculator is so important. Yes, I said that. I don't mind saying it's important, but taking the square root of 25 is not using a calculator. There we go. Let's change that. Let's change that I don't like that. Let's change X. Let's change that to orange. You know how I am with colors. There we go. And they're wanting this area. Right there. Okay, so I want y'all to tell me, what is my setup? From 0 to what? That means I want y'all to communicate.
Is it 1?
Nope. Well, let me do this. E to the x minus e to the negative 4x dx. Look at your graph. What are you going to? This is 0. 0 to what?
Said negative.
Okay, let me try to help y'all out here, because evidently y'all are not seeing it. Okay, here is natural log. I'm sorry. That's e to the x. This is negative e to the x. And this is natural log of 3. And the area that we're trying to find is right here. And it starts at 0 and ends where?
F3.
I'm sorry, I can't hear whisper. What?
ln of 3.
Natural log of what? Somebody tell me what the natural log of 3 is. What is it? No, I don't want you to calculate it. But what is it? What's the outcome of the natural log of 3? It's a what?
Is it a decimal?
Yeah, but what is a decimal? A decimal is another form of a what? Starts with an N.
Next no.
U.
No.
M.
It's a number.
It's a number. See, you go from 0 to that number. Y'all see natural log and y'all think, oh my God, I don't know what to do. It's just a number. Now watch this. You take your handy dandy calculator and let's set up the antiderivative. And there it is right there. I gave it to you. And I'm going to tell you right now, what's the antiderivative of e to the x, people?
E to the x.
And what is the derivative of e to the negative 4x? Now, I told you the antiderivative. I showed you this the first day. You take the e to the negative 4x, and what goes under it?
The negative 4x.
Negative what? Negative
4.
4. And that becomes a positive. So e to the x plus e to the negative 4x over 4, evaluated at 0 and natural log of 3. There's the setup. And here's the setup. Well, I want to show you a trick I learned in the war. E to the natural log of 3 plus e to the negative 4 natural log of 3 minus e to the 0 plus e to the negative 4 times 0 over 4. I'm going to write all this on the next page. We're going to do it by hand because it's not very difficult. So e to the natural log of 3 plus e to the negative 4 natural log of 3 minus e to the 0 plus e to the negative 4 times 0 over 4. Now I want you to use your natural log e and logarithmic properties in here. There's two properties. There's one property right here, and there's two properties right here. And of course, y'all know what anything to the 0 power is. So you can actually do this without having a brain malfunction. I told y'all going to see this in differential equations. What happens when you see e and natural log together? What happens to the e and the natural log?
They cancel.
Bought some new pens today. Dang on, went to Walgreens. They didn't have Sharpies, so I had to get these Bics. I hope they work. Got 2 red pens. I'm going to wait on this one because I got to do another law right here. So that's 3. Somebody tell me what other law I can use right here. What logarithm law can I use right here? Just focus on the negative 4 natural log of 3. What can I do there? We're not going forward until somebody says it.
Could you
Or
bring
I
it
pry it
down?
out of you. What?
Could you bring it down?
Well, the negative 4, I can do something with it. What can I do with it?
Get it by itself.
I don't hear whisper. What?
Get it by itself.
No, you can do something with the negative 4, but it's not get it by itself, but you can do something with it. Think of your logarithm properties.
Can you bring it down below the 3?
Not below the 3, but what? The 3.
Above the 3.
And what rule is that, Miss Gonzalez? That starts with a P. Oh. Power rule. E to the natural log of 3 to the what? Negative 4th power minus 1 plus e to the 0 over 4. I'm expanding this because some of y'all need it. 3 plus, what happens to the natural log and the e?
Cancel.
All right, finish it out. And what is 3 raised to the 4th power? 81?
Yeah, it's 81.
So that's 3 plus 1 over 81 minus 1 plus 1/4. Well, 81 times 3 is 243, so that's going to be 243 over 81. So 243 over 81 plus 1 over 81 minus, well, that's going to be,
5
hold on a
fourths.
second, 5/4. So that's going to be 244 over 81 minus, well, I don't know what 4 will go into, but 5 over 4. Let's see, 81 and 4, 2, 2, 81, 2, 1, 81, 3 to the 4th, 1 and 1. So that's 4 times 81 is 243. Evidently 4 will go in there 81 times. So that's a 243 here. 243 here. 81 will go in there 4 times. That'd be 8. No.
81
let's
times
see.
4 is 324.
I'm sorry, what?
81 times 4 is 324. Is that what you're doing? You're multiplying the
No. 81 will go into 243 4 times. And that's going to be 4 times 244. And that's going to be a 16, a 17, and 976. Somebody check me. What is 4 times 244?
You're right.
And then 4 will go in there 81. Let's see, 81 times 5 is 405. Somebody check me.
Yep.
And then 976 minus, excuse me, is 571. And somebody give me a decimal in case they want a decimal. What's 571 divided by 243?
2.34 or 2.35.
Let's see what they get. I did something. Hold on. I believe that's supposed to be 973.
No, it was right the first time.
Okay. Let's see what I got. I don't know if that's right or not. Let's see what the calculator says. Let's go to the handy dandy calculator and type in math, antiderivative. And we're going from 0, what are we going to? 0 to natural log of 3. 0. Go up here, hit vars, y vars, function. I believe that's y sub 3. And then here is going to be y sub 2, and it's y sub 1. Vars, it's going to be function y1 minus vars function y2 and dx. And go to, what did I not do right? Okay, evidently I didn't like that, so I'm going to put natural log of 3. Thought it would have used that function. And enter. 1.75. Yeah, I thought we got an error somewhere. I think I know where it is because I did this problem. 3/1. Well, what's 3 to the 4th? 3 times 3. Okay. 3 to the 4th is 81, is it not?
It is.
Okay, then I got something wrong somewhere. Somebody multiply 81 times 3 for me.
It's 243.
That's 244.
He said earlier that least common denominator was supposed to be 324, but you made it 243.
Yeah, that's what
Yeah.
I was asking. Like, well,
Yeah, it's supposed to be, well, 324. I don't know where I got that.
no,
But
it is.
what?
It is 324 if you multiply 81 by 4. I thought that was what you were doing for the denominator.
Yeah, 81 times. Okay, there it is. It's supposed to be
Yeah,
324. Okay, I knew. Okay, 324 is the common denominator, and I got 973. Hold on. Let me find my pen. Let me just go over here and do it the way I got it. I should have went by my notes. It'd be 973 over 324 minus 405 over 324. Is that what y'all got? 568 over 324, which is equal to 142 over 81, which is equal to 1.753 ... I know what I did. I thought this was 243. That's where my mistake was. I didn't multiply it in my head. That right there is supposed to be 324.
I can't see your screen.
Oh, sorry. This right here, well, if I could get my mouse is not working. Hold on. Well, why isn't it working? I can't get my whiteboard to come up. Open. Well, why didn't you open? Jerk. All right here, I believe this is supposed to be 324. I'd got it in my head that was 243, so this is supposed to be 324. And that would go right here. 324 would go right here. And yeah. And that's where it would change. So this is not, I knew something was wrong when I saw that 2.35. There we go. There. Somebody that got 1.75, didn't I do it right there? I think I did it right. Okay, it's time for class to be over. We didn't do but 2 or 3 problems, but you can start seeing how these problems can take, a few minutes. That's why I'm giving you the calculator so you can check your work so you won't, go around in circles. You're welcome. All right. Let me take the roll right quick, see who's here. And those of you I call their names, you can skedaddle. All right, like a bat getting out of hell, the way that y'all do.